So for what values of theta is sine theta 0? And apart from 0, if you want to write a general solution, for which values of theta, sine 0 is 0, other than 0, if I want to write the general form, for which values of theta with, yes, n pi. So one way to understand this is, if I use the general definition, what was sine theta? Sine theta was the x coordinate. Sorry, sine theta was the y coordinate, and cos theta was the x coordinate. Where is the y coordinate 0? Y coordinate, this point is plus 1 comma 0. For a unit circle, this is minus 1 comma 0, 0 comma minus 1, 0 comma plus 1. So there are different ways to remember. Using this, sine theta was the y coordinate. Where is the y coordinate 0? At this point and this point. So what is the angle at this point? 0. What is the angle at this point? 180. And if I keep on adding 180, it will come back to this point. So this is 0, this is pi, 2 pi, 3 pi, 4 pi, 5 pi. So sine theta is 0 for n pi. Where is cos theta 0? Pi by 2 and 3 pi by 2. So 90, 270. So odd multiples of pi by 2. So how can you write odd multiples of pi by 2? 2n minus 1 pi by 2, where n is an integer, or 2n plus also, it doesn't matter. So n is an integer, positive, negative. So you can write it as 2n plus 1 pi by 2 or 2n minus 1 pi by 2. Is this clear? No. How did we define sine theta? Sine theta was the y coordinate. So where is the y coordinate 0? This is the y axis, this is the x axis. On the x axis, y coordinate is 0. So what will be the angle at this point? 0. What is the angle at this point? Pi. So sine 0 is pi, sine pi is pi. Sorry, sine 0 is 0, sine pi is 0. If you add 180 to pi, what will you get? 2 pi. So sine 2 pi will be 0. If you add another pi, 3 pi, it will be 0. And tan theta is sine theta upon cos theta. So where will tan theta be 0? Wherever sine theta is 0. So this will also be equal to n pi. And this you could have seen from the curve as well. So if this is sine x, where is it 0? 0, pi, 2 pi, 3 pi, 4 pi. So integer multiples of pi, sin x will be 0. Integer multiples of pi, tan x will be 0. Where is cos 0? Odd multiples of pi by 2. So this is pi by 2, pi by 2, 3 pi by 2. So now it is 0 at this point. If I add pi to this angle, 180 degrees, where will it rotate? It will come here. So what is 90 plus 180? 270. What is 270 plus 180? 450. 450 plus 180, 630. So for odd multiples of 90, it will be 0. So odd multiples of 90 degrees. So cos 90 is 0. Cos 270 is 0. Cos 450 is 0. Generally, we don't need higher values. But if I want to write the general solution, how would I write the general solution? So if I want to write odd integers, if n is, so in this case, n is an integer. If n is an integer, what is 2n minus 1? Odd integer. This is the way to write an odd integer. So what is the way to write an even integer? 2n. If I want to write only even integers, so suppose n belongs to integers, how will I write even integers? 2 into n. 2 into n will always be an even integer. 2n plus 1 will always be an odd integer. Is this clear? So you could have written 2n plus 1 also, it doesn't matter. So where is cos 0? So where is cos function 0? What was cos theta? Cos theta was the x coordinate. So where is x coordinate 0? On the y axis. So what is this angle? 90 degrees. And what is this angle? 270. Now add 180 again. So what is this angle? 450. Here it is 0. So what is this angle? 90. Now, where is it 0? Where is the y coordinate, sorry, x coordinate 0? At this point and this point. So we measure angle from the x-axis. What is this angle? 90 degrees. What is this angle? Add 180 to 90. Can't we use 2 and pi by 2 for cos? 2n pi by 2 n pi. No, no, we are trying not for odd integers. Where is the sine function 0? For what values? So at 0 it is 0. At minus pi it will be 0. At pi it will be 0, 2 pi, 3 pi. So we can't keep on writing infinite values. So if I want to write it in short, how will I write for what values of theta is sine 0? It is 0 for 0, pi, 2 pi, 3 pi. So how will you write it in short? What is 0, pi, 2 pi, 3 pi, pi, minus 2 pi? So how can I write all these values in short? Integer multiple of pi, n pi. Where is this 0? Pi by 2, minus pi by 2, minus 3 pi by 2. Where is the cos function 0? Pi by 2, 3 pi by 2, 5 pi by 2. Why is it 0 here? If that is not clear, that you can understand from this, the definition. What was cos theta? Cos theta was the x coordinate for the unit circle. So where is the x coordinate 0? On the y-axis. Where does it cut the y-axis? At this point and this point. What will be the angle at this point? 90 degrees. What is the angle at this point? 270 degrees. What is this angle when you come back here? 360 plus 90, 450. So at this point it is 0. So add 9. What is this angle? 90 degrees. Now add 180 degrees to 90 degrees. What will you get? It will get this point. So 90 plus 180 will also be 0. Add 180 to this. Where will you get? 180 means it will rotate to diametrically opposite point. So 90 plus 180 plus 180. For this also cos will be 0. So what is this? 90. What is this? 270. What is this? 450. So where is the cos function 0? Pi by 2, 3 pi by 2, 5 pi by 2. So how will you write this in short? These are what? integer multiples of pi by 2. Sorry, odd integer multiples of pi by 2. So how do you write an odd number? 2n minus 1, where n is an integer. Is this clear to others as well? Now, the approximations that we did yesterday, the trigonometric approximations, we could have done this in another manner as well. So, the functions. Now, another way to do approximations is using Taylor series. So, we won't be studying what Taylor series is or what Taylor expansion is. I'll just be giving the expansions directly, because that is not needed. So before we study series expansion, sorry, I'll just write the factorial notation. So you've studied factorials. So what is a factorial? Factorial of any integer, if n is an integer, so n factorial, so it is represented by n exclamation mark or this. And what is this equal to? If n is a positive integer, it is defined as n into n minus 1 into n minus 2 so this is called factorial. So these are the two common ways to denote a factorial. So functions can be expanded in terms of power series. So 1 plus x to the power n. So we don't need to remember this binomial expansion. This you'll study in mathematics, binomial expansion. So why are we using this? What we need is binomial approximation. So this is valid for yes? Yes, yes, sorry, thanks. So mod for mod x less than 1, and n is any real number. So this we don't need to remember. What we need this for is binomial approximation. So in a lot of calculations, we use this approximation. So what is binomial approximation? Now, if mod x is greater than 1, then this series does not converge, it diverges, so it becomes infinite. So this series is valid for mod x less than 1, n is any real number. If mod x is much, much less than 1, if it is a very small number, so suppose we take a number 0.01, what is square of 0.01? 0.0001. What will be cube of 0.01? 0.00001. So when you square a small number, the number further decreases. So there was a question in the trigonometric worksheet based on this as well. Tan theta to the power tan theta. Did you try that question? So it was based on the similar concept. So we'll discuss the worksheets together today and yesterday's. So binomial approximation, if mod x is much, much less than 1. Now, if x is much, much less than 1, can I say x square will be even smaller? X cube will be even smaller. So this is an infinite series. Can I neglect all the further terms? So if mod x is very small, I can neglect the further terms. So in this case, if mod x plus 1 is much, much less than 1, can I say 1 plus x to the power n is approximately equal to 1 plus nx. So what we need is this approximation. This series you'll study in maths. You'll even study the general form a plus b to the power n. Now, what we need for physics is the binomial approximation. So what is the binomial approximation? If the magnitude of x is much, much smaller, then I can neglect the higher order terms, x square, x cube, x to the power 4. So 1 plus x to the power n can be approximated as 1 plus nx. So this is known as the binomial approximation. That is the binomial expansion. So try a few questions based on this. So here n belongs to a real number, which means it can be positive, negative, fractional. N is not an integer here. So just real number means it can be positive, negative, fractional. So this n does not have to be an integer. Suppose I want to calculate the approximate value of root 103. So can you think of a way to apply binomial approximation for the calculation of this? If I want to calculate the square root of 103, one method is we can use the way we calculate the square root. But suppose I want to use binomial approximation to calculate the square root. So approximate value. Can you think of a way to apply this? What is the meaning of square root? Can I write it as 103 to the power 1 by 2? Now, I want to write it in the form of 1 plus x to the power n. So now, try to think of the perfect square which is closest to this number. This power here is square root. So try to think of the perfect square. If this was cube root, try to think of the perfect cube. So which is the perfect square closest to this number? 100. So can I write it as 100 plus 3 to the power 1 by 2. Now, can you reduce this to this form? So can you reduce this to this form? How can you reduce? If I take 100 common, if you take 100 common outside, can I take 100 common outside? Yes. What will it become? Square root of 100. What is square root of 100? Or if it is still not clear, first, before taking common, you can write it as this manner. Can I write it as this? 100, 1 plus 3 by 100 whole to the power 1 by 2. And what is 100 to the power 1 by 2? 10. So can I write this as 10, 1 plus 0.03 to the power 1 by 2. Now this is of the form 1 plus x to the power n. So what is 1 plus x to the power n? Approximately equal to 1 plus nx. So what will be the value roughly equal to? 10 into 1 plus 1 by 2 into 0.03. So this will become how much? 0.03 is 0.015. So 10 plus 0.15, 10.15. Is this clear? And if you calculate the exact value, so square root of 103 is 10.14889. So approximately it is equal to 10.15. So now, again, till what values can we use this? The point is, the smaller is the value of x, the better will be the approximation. So there is no fixed value till we can use this. That depends on what degree of accuracy we need. The point is, the smaller is the value of x, these terms will be even smaller. So their contribution will be even smaller. So the answer will be more accurate. So there is no fixed value, but the smaller the x, the greater will be the accuracy. Try another question. So next, calculate or cube root, I think. You can write it in this manner. So what will be the approximate value of 997 to the power 1 by 3? So 1000 minus 3. So now find the perfect cube closest to 997. That is correct. So the point here is, whatever is the power here, If it is 1 by 3, you need the perfect cube. If it is 1 by 2, you need the perfect square. Why? Because when we take it outside, we need cube root, square root. So if I take 1000 outside common, what is cube root of 1000? 10. So 10 minus 3 by 1000 to the power 1 by 3. Not with 1000. So this is whole to the power 1 by 3. Na? So when you take 1000 outside, this is also 1000 to the power 1 by 3. What is 1000 to the power 1 by 3? 10. So basically, outside here you won't get 1000. This will be 1000 to the power 1 by 3. So this is again of the form 1 plus nx, 1 plus x to the power n. So this will be 1 plus nx. X is minus 3 by 1000 in this case. So x can be negative as well. So 1 plus nx, n is 1 by 3 into 3 by 1000. 3 and 3 will cancel out. So this is 10 into 1 minus 0.001. So we'll get 9.99. Is this clear? Now, the other places where this is used in physics is in derivation of certain formulae. So suppose I want to write when we derive certain formulae, suppose I want to write the formula for gravitational field for external points. If I'm writing at this point, which is at a distance r, suppose the point is at a distance r from the center, and this height is h. So now, the gravitational field at a distance r from the center of the earth, the gravitational field at a distance r from the center of the earth is given by the formula gm by r square. Now, suppose I want to find the gravitational field close to the surface of the earth. H is small. So before we write h is small, let me write this. Suppose m is the mass of the earth, r is the radius of the earth, and small r is the distance of the point from the center of the earth. This formula is only for external points. For internal points, the formula is different. So if we assume the earth to be a perfect sphere of uniform density, this is the formula we'll study in the chapter of gravitation. Now, G is gm by r square. How can I write small r in terms of capital R and h? Can I write it as gm upon r plus h to the power whole square? Now, this is the general formula. So generally we use it in this form. When is this used? Suppose they're asking you in terms of height from the surface of the earth. So whenever we say height, we don't mean from the center of the earth, we mean from the surface of the earth. And if h is much less than r, what is the value of radius of the earth? What is the radius of the earth approximately? Any idea? Yes, around 6,000 kilometers. It's around 6,400 kilometers. That is the radius of the earth. So if h is much less than r, so even if you're talking about a few kilometers, so in that case, rather than using this formula, we can make an approximation here. So if h is much less than r, using binomial approximation, can you simplify this expression? Using binomial approximation, can you simplify? Can I write this as g is gm upon r gm upon r square 1 plus h by r whole square? Can I write it in this manner? Now, here for this, if h is much less than r, so even if it is a few kilometers, that is much less than 6,400 kilometers. So we can use the binomial approximation. But whenever you are using the binomial approximation in such cases, rather than applying binomial approximation to this quantity, if it is in the denominator, always take it to the numerator and then apply binomial approximation. It will be correct even if you apply binomial approximation here. Why I'm saying this, I'll just explain in a while. So for such quantities, if the expression is in the denominator, before you apply binomial approximation, it's convenient if you take it to the numerator and then apply binomial approximation. So suppose g is gm by r square. If I take this to the numerator, what would this become? 1 plus h by r to the power minus 2. So now n can be any number. N is any real number. It can be positive, negative. It can be an integer as well. So if I apply binomial approximation to this, what will I get? So till now it is equal to, I'll get this is approximately equal to gm by r square 1 minus 2h by r. So this will be the binomial approximation. So this is used in derivation of certain formulae as well. So there is another formula given in today's worksheet. So we don't have to understand the meaning of the formula in terms of power. There's a certain formula E sigma A. So again, simplify the formula using binomial approximation. Try that for homework. Now, why did we say if I applied binomial approximation in the denominator? Suppose in this question, if I applied binomial approximation in the denominator, what would I get? R square 1 plus 2h by r. Now this value will almost be same as this value, but why do we prefer this? Because it is easier to calculate. So now gm by r square, this is 9.8. For questions generally we take it as 10. Acceleration, the gravitational field at the surface of the earth is approximately 9.8, which is what we also call acceleration due to gravity. So if I suppose I take it as 10, so gm by r square, this is approximately 10. And now I want to calculate 1 plus 2h by r. Suppose 2h by r is 0.002. Now, is this easy to calculate, or 10 into 1 minus 0.002? This is easier to calculate than this. Is this clear? So if you applied binomial approximation in the denominator itself, you'll get an expression of this form. And if you take it to the numerator, you'll get an expression of this form. So it is easier to multiply than divide in this manner. So generally, whenever you're using binomial approximation, if the function expression is in the denominator, take it to the numerator and then apply binomial approximation. Is this clear? Yes. How did r square become? What is r? R is the radius of the earth. This distance is r. This is capital R. This is h. Total distance is r. This is capital R. So small r is capital R plus h. Is this clear? So when you heat a liquid, what happens to the volume of the liquid? It generally, if you heat an object, what happens to its volume? It generally increases. So water shows anomalous behavior from 0 to 4 degrees, but in general, if you heat an object, it increases. So when your jam bottles are too tight, what do we generally do? We dip it in hot water. What happens? The cap is generally made of metal. So its size increases, it loosens, we can easily open it. So for most objects, when we heat them, the volume increases. Now, have you written this part? So another formula for density is, so volume increases means density decreases. So this comes out to be rho is rho naught 1 plus gamma delta T. Now, for solving such questions, we apply binomial approximation even in this. So can you simplify this using binomial approximation? So this is a formula for change in density. So if we increase the temperature, so rho naught is the initial density, I have increased the temperature by delta T. So what will happen to the density? It generally decreases. It can increase as well, but that is not the normal behavior. So when we heat an object, generally its volume increases. If the volume is increasing, what will happen to the density? It will decrease. So this is a formula for change in density. Now what is the meaning of these terms? We don't need to know. Gamma delta T is temperature, change in temperature. Now can you simplify this using binomial approximation? So in such cases, again, sorry, I forgot to mention, gamma delta T is much less than 1. So gamma is called coefficient of volume expansion. The value of gamma is generally in the order of 10 to the power minus 5, 10 to the power minus 6. So gamma is generally quite small. So if gamma is 10 to the power minus 5, even if you are increasing temperature by 100 or 1000 degrees Celsius, this term is still much less than 1. So generally when we are increasing the temperature, we won't go beyond 1000 or 2000. So now gamma is of the order of 10 to the power minus 5. So even if you're increasing temperature by a few 100 degrees Celsius or even 1000 degrees Celsius, gamma delta T is still much less than 1. So now try to simplify this using binomial approximation. How else can I write this? Using binomial approximation. Do you have class tomorrow as well? Huh? Sunday you have class. The test is on Monday, I think, from now onwards. So I think Saturday you'll have class, Sunday is probably holiday, I guess. I'll ask there. So what will this become? So this is again of the form 1 plus x to the power n. Now, can I write it as rho is, or let me write it on the next page. So rho is rho naught 1 plus gamma delta t to the power minus 1. Is this of the form 1 plus x to the power n? So can I write it as 1 plus nx. What is n in this case? Minus 1. What is your name? Mohit. Mohit, please listen. So what this is of the form 1 plus x to the power n. So this will be 1 plus nx. N is negative. So this will be minus gamma delta t. So now, again the point here is, sometimes if they've given you the question in terms of variables, then this may be present in the options, then you don't need to simplify. But in certain questions, they give you the values. If they've given you values, delta t is 200 degrees Celsius, gamma is 2 into 10 power minus 5, then to calculate this value would be difficult. So it's easier to calculate in this form. And sometimes the answer is also given in this form. So you should be able to convert this into this. Sometimes the answer is given in this only, then you just check in which form they've given the answer. Is this clear? So the first expansion that we saw was of binomial expansion. So in case of binomial expansion, I said we don't need to remember the expansion series, we just need to understand the binomial approximation. But there are a few other expansion series which we need to remember. So e to the power x is 1 plus x square by 2 factorial plus x cube by 3 factorial. Now, if mod x is much less than 1, again e to power x expansion, this is the expansion series for e to power x. If mod x is much less than 1, what can I approximate e to power x as? 1 plus x. If mod x is much less than 1, x square, x cube, these terms can be neglected. So this will be approximately equal to 1 plus x. You've written this? So now, this expansion series is generally used in two ways. One is, if I substitute x equals to 1 in this series, what will I get? For x is equal to 1, what will this become? ln 2. What is the meaning of ln? We'll see later today. So this is log basically. ln 2, this will become equal to 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus. So in certain questions when we solve, this series appears. So you should know that this series is equal to ln 2. And where else is it used? For mod x much less than 1. In a couple of questions in JEE mains, the answer was of this form. But the actual answer that they gave, in that case, they're not given in terms of ln 1 plus x. So you were expected to remember the first two terms of the expansion. So now, the eventual, I've forgotten the exact question, but in the question it was something like this: 1 plus alpha, some constant. And this value was much less than 1. Now, had they left the answer in this form, there was no need to expand this, but they're not given the answer in terms of ln. So basically, you were expected to remember the first two terms of the expansion series. So for mod x much less than 1, what can I write? ln 1 plus x as? I can write it as x as well. But in the answer, there were two terms present, which means they've taken first two terms for the approximation, which means you'll need to remember the series only. Is this clear? So you can approximate it as x. If you want a better approximation, you can take multiple terms, but in the question they've taken the first two terms there. Basically, if x is small, x square will be even smaller. So technically, if you're taking 2, why not take 3? It will be even better approximation. But the point is, in the questions, they've taken it, so you should remember the expansion. So similarly, these series are known as Taylor expansions, Taylor series. So for different functions, we can expand them about different points. Now, again, from this also we can see, for small x, what can I approximate sin x as? X. This we've already seen earlier as well. So if x is small, x cube will be even smaller, x power 5 will be even smaller. So I can approximate sin x as x. So for small x, what can I approximate cos x as? 1. But in certain cases, we use x square by 2 factorial. What is 2 factorial? 2 factorial is 2 into 1, 2. So how do we calculate factorial? 1 factorial is 1, 2 factorial is 2 into 1. 3 factorial is 3 into 2 into 1, 6, and so on. So 2 factorial is 2, so we can approximate it as 1 minus x square by 2. So for yes. Huh? Why are there only odd numbers? Sorry, these are all. So why are there only odd numbers here? That I haven't explained. I haven't done the derivation of the Taylor series. No? How are these derived? So that we are not studying right now. So for none of the series I've explained the derivation. So that we don't need in our syllabus. So tan x, so again for small x, this is not factorial here. This is 1 by 3, 2 by 15. So for Monday's test, generally whatever we cover till Friday or Saturday, it depends, I'll just inform. So everything that we've done, so even the previous weeks, units and dimensions and the current weeks will come for the test. Is this clear? Now, next, again, so next, we just need an introduction to what is logarithms. We won't study logarithms in physics. That is again a chapter in mathematics. But what is log, that we'll study, and a few rules, few properties of logarithms. So suppose we say if y is equals to sine x. So what can I write x as? If y is sine x, what can I write x as? Sine inverse of y. That was inverse trigonometric function. What was inverse trigonometric function? What is the meaning of sine inverse y? Sine inverse y, what is the meaning of this term? This is an angle whose sine gives us y. It's an angle, I'm not writing it again, we've done this yesterday. So, if y is sine x, x is sine inverse y. So this is the inverse function. So suppose y is x to the power 5. So what will be the inverse? This is known as power function. So what will x be equal to? What will be the inverse of this? X will be equal to y to the power 1 by 5. Is this clear? So this is also a power function only. So y is x to the power 5. In that case, x is equals to y to the power 1 by 5. So what is logarithms? So next, write what is an exponential function? What is an exponential function? What do you mean by an exponential function? Exponential function means some number to the power x. In the power function, it is the variable to a power. And here, the power is in, the variable is in the exponent. So these kind of functions are known as exponential functions. The most common exponential function is e to the power x. E is a constant. So next, write logarithm. So these functions are known as exponential functions. So suppose b is some number. If y is 2 to the power x, if y is x square, what will x be equal to? Square root of y. If y is x square, what will x be equal to? Square root of y. Now, suppose we have an exponential function. If y is 2 to the power x, then what is x equal to? So logarithm is basically an inverse of exponential function. So this, what is sine inverse of y? This is just a notation. This is just a way to write the inverse function. Similarly, logarithm is again a notation to show the inverse of a exponential function. So if x is b to the power y, y is written as log x to the base b. So what is the meaning of log x to the base b? So this means the base should be raised to what power so that I get x? If y is equals to log x to the base b, so basically it is the exponential function inverse of this function. If x is b to the power y, I want to calculate the value of y. Suppose y is sine x. So what is x? X is sine inverse y. So we call this the inverse trigonometric function. Similarly, if x is b to the power y, what is y equal to? The way we write it is log x to the base b. So what is the meaning of this term? To what power should I raise b so that I get x? What is the meaning of log x to the base b? Log x to the base b gives us the power to which b should be raised in order to get x. Is this clear? You've written this part. So what is the meaning of log x to the base b? To what power? This value gives us the power to which b should be raised in order to get x. So now, in this case, if log 1000 is 10 to the power 3, so what can I write this as? Log 1000 to the base 10. What will this be equal to? 3. So what is the meaning of the left hand side? If I erase the right hand side, what is the meaning of log x to the base b? This term gives us the value to which b should be raised in order to get x. So to what power should 10 be raised in order to get 1000? 3. To what power should 10 be raised in order to get 1000? 3. So log 1000 to the base 10, this will be equal to 3. Similarly, if 16 can be written as 2 to the power 4. So in a similar manner, what can I write here? Log 16 to the base 2. What will this be equal to? 4. Is this clear? Please note. Mohit. Right? Achha, so you've written. Suppose 1 by 9, can I write 1 by 9 as 3 to the power minus 2? So what will this become? Log 1 by 9 to the base 3 is equal to minus 2. Is this clear? So to what power should I raise 3 so that I get 1 by 9? Minus 2. What is b to the power 0? Any number to the power 0? Except 0. Any number to the power 0 is 1. So what will this become if you write in this manner of logarithms? Log log 1 to the base b is 0. To what power should I raise b so that I get 1? Now b here can be any number. For any number, if I raise it to the power 0, I get 1. So log 1 to any base is equal to 0. Is this clear? Now, what are the possible values of b? What are the possible values of the base? So what are the values that b cannot take? So one value that it cannot take is 1. Why? 1 to the power, so suppose 1 to the power any number. One to the power any number is equal to 1. So when I write it in this form, log 1 to the base 1. Now, logarithms is not defined for base 1. Why? You'll get infinite such values. 1 to the power any quantity is 1. 1 to the power 0, 1 to the power 1, 1 square, 1 to the power 3 by 2. 1 raised to any number is 1. So for base 1, it is not defined because you get infinite values. And For what other values is b not defined? What are the possible values that b can take? It cannot take 1. Why can't it take 1? Because you get infinite answers in that case. What other values can b not take? Any negative or 0. Why can't it take negative numbers? So suppose if the base is negative, what is minus 2 to the power 4? What is minus 2 to the power 4? 16. What is minus 2 to the power 2? 4. What is minus 2 to the power 1 by 2? What is minus 2 to the power 1 by 2? Not defined. It is root of minus 2. Can you take square root of a negative number? So we study complex numbers, but that is later in maths. Root of minus 2 is not a real number. So again, if you take base as negative, so for certain values, again the function won't be defined. Is this clear? If the base is negative, if you're raising the number which is negative, so if I'm raising a negative number, minus 2 to the power 2, in that case it can be defined. Minus 2 to the power 2 is 4. But what is square root of minus 2? That is not a real number. So the base cannot be negative, it cannot be 0, and it cannot be 1. So if x is b to the power y, log x to the base b is equal to y. So now this number will always be positive if b cannot be negative. A positive number to any power will always be positive. So logarithms is defined only for positive numbers, and the base, what are the possible values of the base? Base can be any number greater than 0 and not equal to 1. Is this clear? So for our purpose, we just need to understand what is the meaning of logarithm, and I'm writing a few properties. We are not deriving that because you'll study this chapter in maths. So now, generally when we write log x, if the base is not written, the convention is the base is taken as 10. In few questions, they might make a mistake, they might mean ln and it is 10, so just be careful. But generally, if the base is not written, they mean base logarithm to the base 10. And if they're writing ln, what is the meaning of ln? Ln means log to the base e. So the number e, this is an irrational number. The first 4 digits are 2.718. So this is also known as Euler's constant. This number has a few special properties, one of those which we'll study next week when we study differentiation. So this number has a certain special properties. It occurs whenever the natural rate of growth. So whenever we study rate of growth of certain quantities, this number appears in those expressions. So now, if the base is this Euler's constant, E, so that is known as natural log. In that case, the symbol is ln. So the ln that we wrote earlier in the expansion, ln 1 plus x, what was this basically? Log 1 plus x to the base e. That was the meaning of ln 1 plus x. Is this clear? In one of the formulas earlier I written ln 1 plus x. So what was ln 1 plus x? It was log 1 plus x to the base e. So please note a few properties. What will be log 1 to the base b? 0. What will be log b to the base b? What will be the value of ln e? Similarly, what will be log 10? 1. So any number to the same base will be 1. To what number should I raise b so that I get b? 1. Can you write for log fifth property log x upon y on your own? What will be log x upon y to the base b? Log x y, x into y is log x plus log y. What will be x upon y? So x upon y is same as x into y to the power minus 1. So this will become log x plus log y to the power minus 1. The power we can take it out in front. So this will become log x minus log y. You've written the first 4 properties. So this property again, we don't use this in physics generally. The only case where we use this in physics is to derive this expression. So we can just remember the expression for now, the relation that I'm deriving. So now, this is the formula for change of base. If I want to change the base, so now log x to the base e can be written as log x to the base 10 upon log e to the base 10. And the value of log e to the base 10 is, even I don't remember the value, 1 divided by log e to the base 10. This gives us 2.303. So for our purpose in physics, even if we don't remember the change of base formula also, all these and even more formula you'll study in maths. So you don't need, even if you don't remember this formula, this relation you can remember. And a few values that are needed are log 2 to the base 10. This is 0.30. Log 3 to the base 10 is 0.4771. ln 2 so ln 3 so these are few values which are sometimes used in questions, so it's helpful if you remember those. So this, even if you don't remember right now, whenever it is required in questions, gradually you can remember these. Yes? Natural log means basically log x to any base. So generally when we write log x, if nothing else is written, this means log x to the base 10. If the base is not mentioned, the convention is base is 10. Log x to the base, you can have any base. Log x to the base e, where e is a constant. This is called natural log. Now, why have we created a special symbol for e? Because this number has certain special properties. We won't study those properties in physics. One of those properties we'll briefly study next week when we study differentiation. So log x to the power 2, we can have any base. If the base is e, Euler's constant 2.718, if it is that number, then it is called natural log. What is? K is any base. So in this case, I've chosen 10. If ln x is alpha, what can I write x as? If ln x is alpha, what can x be written as? E to the power alpha. So basically, if log x to the power b is any quantity. So what is x equal to? X is b to the power y. So ln x means base is e. So this we'll be using a lot. Whenever we get ln x is some quantity and they're asking you x. So if ln x is alpha, what will x be equal to? E to the power alpha. Is this clear? So now next thing that we need is very basic coordinate geometry. So basically equation of a straight line, equation of a circle, equation of a parabola. And what do the graphs look like? So first is straight line. So slope of a straight line is defined as tan of theta, where theta is the angle that the line makes with the positive x-axis. So suppose we have two straight lines. Now, if this is theta and this is theta, what will be the slope in this case? If this is the direction of positive x-axis, x-axis is in this direction. So slope is represented by m generally. Now, what will be the slope of this line? Tan theta. What will be the slope of this line? What will be the slope of this line? tan of 180 minus theta, the angle that the line makes with the positive x-axis. So slope of a line is defined as tan theta, but theta is the angle that the line makes with the positive x-axis. So if this angle is given as theta, what is the angle that the line makes with the positive x-axis? 180 minus theta. So what will be the slope of the line? Tan 180 minus theta. This will be equals to minus tan theta. So if the angle is given with the positive x-axis, slope will be tan theta. If the angle is given with the negative x-axis, slope will be minus tan theta. Is this clear? Now, how can we write the equation of a straight line? So 2-point form means if 2 points are given to us and I want to write the equation of the straight line. So this is 1 point, the coordinates of this point are x1, comma y1. The coordinates of the second point are x2, comma y2. Now, I want to write the equation of this line. What is the meaning of equation of the curve? What is the meaning of equation of any curve? Relation between x and y coordinates. For any x, what is the relation between the x and y coordinate? That is called the equation of a given curve. So now, if I know 2 points which lie on this straight line and I want to write the equation of this straight line. So how can I write the equation? So suppose x comma y is any arbitrary point on this line. The 2 points that are known to me, what are the 2 points? x1, y1, x2, y2, these are constants. 2, 3, 1, 4. These are constants which are known to me. X, y, these are variables. X and y is a variable, which is any point on this line. Now, for a straight line, can I say slope of a straight line is constant? The slope of a straight line is constant. What can you write tan theta as? Can I write tan theta as, if this angle is theta, can I write tan theta as opposite upon adjacent? So, if if this angle is theta, can I say the slope of the line is tan theta? So can I write the slope as y2 minus y1? Next is the slope intercept form. So what was the 2-point form? 2 points were known. I taken x1, y1, x2, y2. When we say slope intercept, we mean the y-intercept. What is the meaning of intercept? Intercepts are the points where the straight line cuts the x and the y-axis. In slope intercept form, we mean the intercept is the y-intercept. So if this is the straight line, the coordinates of this point, suppose these are 0, c. So what is c known as? C is the y-intercept. This point would be the x-intercept. In this case, it is negative. So what is given to us? Y-intercept and slope are known. So now, in this equation, in the previous equation that we've already derived, if I substitute the values, what is this term? What is the term within the brackets? That is the slope. So y minus y1. So now can I say the slope is known to me, m is known to me, m is the slope. Now what are the coordinates of this point? 0, c. So if I choose this point as x1 and y1, in this case what will I get? The y1 is c, what is x1? 0. So in this expression, if I substitute the values, y minus c is equal to y2 minus y1 upon x2 minus x1 into x minus 0. And what can I write this as? M. This is the slope. The slope is known to me, so I can write it as m. So what will this become? Y is equals to mx plus c. So if the slope of the line is known to me and the y-intercept is known to me, the equation of the straight line will be y is equals to mx plus c. Is this clear? Did you understand this? In the first equation, now the y-intercept is known. So x1 is 0, y1 is c, and the term within the brackets is also known, that is m. So this equation will turn into this equation. So when we say the intercept form, both the x and the y-intercept are known to us. So again, if I use the previous relation that we derived, y is equals to mx plus c. What is the slope of the straight line? Aditya. So it is helpful unless your parents are extremely rich. In that case, it's fine, you can continue sleeping. But it is helpful to think, contemplate. So even I struggle with it. Why it is important? It has a certain benefits. This is not the most important thing in life that you have to figure out on your own, but it has a certain importance. So once you realize why it is important, in that case, you won't be asked to put in the effort. It comes on your own. Now, what is the slope of this line? Timothy, what will be the slope of this line? For this straight line, what will be the value of slope? So how did we define slope of a line? If this is a straight line, tan theta is defined as the slope. Basically b by a and negative, minus b by a. What is the slope of this line? Slope of this line is tan theta or minus tan alpha. Slope of a line is defined as tangent of the angle that the line makes with the positive x-axis. And if the angle with the negative x-axis is given, it will be minus tan alpha. That is the definition of slope. That is how we've defined slope. So now for this, if this angle is alpha, what will be the slope of the line? Tan alpha or minus tan alpha? Minus tan alpha. If this angle is given to us, theta is given to us, slope will be plus tan theta. If alpha is given to us, slope will be tan of 180 minus alpha. Tan of 180 minus alpha is minus tan alpha. So what will be the slope of this line? Can I write it as minus tan alpha? And what is tan alpha? Opposite upon adjacent. What is this length? B. What is this length? A. So what will be tan alpha? B by A. So can I write slope as minus B by A? So now substitute the values here. Y is equals to minus bx by A plus, what is the y-intercept? Y-intercept is B. Now rearrange this and check if this is correct. So this is the intercept form where A is the x-intercept, B is the y-intercept. Is this clear? So generally when we are writing the equation of a line, we'll use either of these three forms. How did we get this? This is just calculation. Now this you'll have to try on your own. So how do we get from here to here? Take this to the other side. So if I take this to the other side, what will I get? Y plus bx by A is equal to B. Now, Divide both sides by b. So what will I get? Y by b plus x by a is 1. So this you'll have to rearrange on your own. Is this clear? So whenever you want to write the equation, depending on what information is given to us, if intercept is given to us, we can use, if both the intercepts are given, x by a plus y by b is equals to 1. If slope intercept is given, y is equals to mx plus c. If 2 points are given, we can use in this manner. And this is also applicable for, I'm not writing it separately, if slope and 1 point is given other than y-intercept. How did we calculate this equation? By using this only. Slope was given and 1 point was given. So if slope is given and 1 point is given, but that 1 point is other than the y-intercept. So again, y minus y1. What will this become? Y minus y1 is m into x minus x1. So this is the slope and any 1 point is given, this will be the equation. So this is same as this, I'm not writing it again. Is this clear? So where do we require this in physics? So this is frequently used. A lot of the graphs are straight lines. There we'll be needing this. Sometimes they'll give you a quantity varies linearly. What is the meaning of linear variation? So suppose if they give you y varies linearly with x, this means the curve is a straight line. Y varies linearly with x, what is the meaning of that curve? Sorry, what is the meaning of that statement? The power of x is 1. If the power of x here is 1, the highest power is 1, in that case we say y varies linearly with x, which means the equation is a straight line. So one of the uses is, let's see an example. Let's use now suppose this is a solid sphere of radius r. Write a question. The density of the sphere varies linearly with r. The density small r, the density of the sphere varies linearly with small r and is rho naught at the center and 2 rho naught at the surface. And 2 rho naught at the surface, full stop. So find density as a function of r. So what is r? R is distance from the center. Now the density is not uniform. So in questions they won't ask you rho of r. Rho of r will be required to solve some other part. So in questions they won't be asking this, but you'll have to find this to solve other parts. Now what is given to us? The density is not uniform. What is the meaning of uniform? Uniform means is same everywhere in space. So the density is same throughout. That is known as uniform. In this case, the density is non-uniform. It is varying. Now, what have they given us? The variation is linear. The density is varying linearly with small r, with r. R is the distance from the center. The density at the center is given as rho naught. The density at the surface is given as 2 rho naught. We want to find density as a function of r. At a distance small r, what will be the density of the sphere? Now, how is this required in questions? That when we solve the questions, we'll see. But in these kind of questions, while writing the expression for rho of r, we'll again need the equation of a straight line. So can you think of a way to write what will be the equation of this straight line? Can you draw the straight line in this case? If I draw, so generally if I want to write the equation of the straight line, it is convenient if I draw the straight line. So which quantity is varying? Density. Yes. Rho naught into r. Rho naught into, that is dimensionally incorrect. So when you say rho is rho naught into r plus rho naught. Now, what is the dimension of this quantity? Density. Rho naught is also density. Sometimes they'll give you rho is rho naught into length. Here rho naught is not density. But I have given rho naught as density only. So what is the dimension of this quantity? Density. What is the dimension of this quantity? Density. What is the dimensional formula for this quantity? Density into length. So this is dimensionally incorrect. This cannot be correct. Is this clear? So these kind of questions, in these kind of questions, again we need to write the equation of a straight line. So it is convenient if you first draw the straight line. I am plotting rho versus r. When r is 0, at the center, what is the density at the center? The density is rho naught. At what point is the density 2r? Radius of the sphere is given to us. Radius is capital R. So the radius of the sphere is capital R. Density at the surface is given as what quantity? 2 rho naught. And what else is given to us? The quantity is varying linearly, which means it is a linear relation, means the curve is a straight line. So from rho naught to 2 rho naught, sorry, this is capital R, this is 2 rho naught. Is this clear? What have they given to us? The density at the center. At the center, what is the value of r? 0. Small r is distance from the center. Small r is distance from center. So when r is 0, at the center, what is the density? Rho naught. When r is capital R, at the surface, what is the density? 2 rho naught. And what else is given to us? The quantity varies linearly. If the quantity is varying linearly, means the curve will be a straight line. Is this much clear? Now we have to write rho versus r. Rho versus r means writing the equation of this straight line. So now can you write the equation of this straight line? Please write the equation of this straight line. forgotten your name. What is your name? Huh? Yakia. Is this correct pronunciation? Yakia. Yakia. Yes. So which equation should I use to write the equation of straight line? Slope intercept form. If I use the slope intercept form, so y is equals to mx plus c. What is y in this case? Density. What is x in this case? R. Now, y is rho. What is the slope of this line? Tan theta. If this angle is theta, can I say slope is tan theta? What is this length? Rho naught. What is this length? R. So what is tan theta? Rho naught upon R. This length is how much? 2 rho naught minus rho naught. What is this length? Capital R. So what is the slope? Rho naught by R into x. What is x? Small r. And what is c? C is the y-intercept. What is the y-intercept in this question? Rho naught. So rho will be rho naught r upon r plus rho naught. Is this clear? So they won't ask you this question, but it will be used in calculating other quantities. So suppose they're asking what is the mass of the sphere. They won't even ask the mass of the sphere, but suppose the mass is needed for some other calculation. So for calculation of mass, first I need to write density as a function of r. So in such cases, we need to write the equation of a straight line. Is this clear? So some other curves we'll study tomorrow if we have a class, otherwise on Monday or whenever is the next class. So today again you'll get a worksheet. So there is one worksheet on basic trigonometry and some approximations and one question on straight line. And there is another worksheet which has some graphs as well. Leave those graphs for now because we haven't studied those graphs. So in that worksheet, one is a handwritten one. The handwritten one you can try all the questions. The other worksheet, so these are basic questions. There are few questions on log as well. I've not done any questions on log, but you just have to apply the formulae. So you can just see the formula and just apply those. And a few basic, very simple questions on trigonometry, just formula based, just for revision of formula. And there is 7-8 questions, handwritten questions, try those as well. So have you solved the previous worksheets completely? So this and the previous one we'll discuss tomorrow, all the doubts. And after this, so there are few more equations, equation of a circle, parabola, a few other curves, then shifting of curves, few graphs, how to plot some graphs. So that will require at least 1 or 1.5 class, and then we'll begin with differentiation functions. Is this clear? So please finish the homework.
I will message you again if I'm targeted again.
I have shared
Ah,
his
yeah,
number.
I saw it yesterday.
I asked them to come and meet. We'll
That
sort
is,
out the things.
yeah, yeah, that is okay.
Instead of him, actually, we have to sort it out
Yeah,
because
yeah.
we are also getting irritation that anyway
Yeah,
this child
no,
is.
I will tell you my experience as a teacher. This child is a problem child. The parents also know. Okay,
In the message also they
it's
have mentioned.
it's not the first time that is happening. He knows how to handle. They also know how to handle. It's we who have to get adapted to it. See, something like this cannot happen like just like that. He's doing this in the school
And
also.
today the light, somebody, everybody on off is
No,
going
I
to
will
be.
go now in that batch.
If anything is there, please
Yeah,
message
yeah,
me.
yeah. Sure, sure. I will. Good afternoon. Sit down. So some basics of mathematics is being done is good, right? So you learn about straight line and all will help you drawing graphs. Yes or no? That day when I was talking, you were quite lost. Now again look at the graphs that we did in photoelectric effect. Maybe you will understand them in a better way now, right? So this is good. That is happening. Now, yesterday I gave you one worksheet. Problems pertaining, I have that. Just 20 question worksheet. Today physics worksheet will come. And your this week also you will have ITS 3 exam. So that date time will be told to you. But there is a exam ITS 3. My syllabus will be atomic structure this year, this week, sorry. Not this year. You will write atomic structure and I am planning a mixed test in ITS 4. That will be next week. So I am announcing you in advance. So this weekend or this week's test, whenever you write, that will be ITS 3 syllabus is atomic structure. And in ITS 4, I will add some problems of mole concept as well. Though my main focus will remain on atomic, but something will come from mole concept so that you will revise maybe in between. You are not revising mole concept because we are doing atomic now. So like this, I will keep adding old chapters. And that is what is required because otherwise if something is taught today, you can't remember it 2 years down the line. We do have to add this way. This is called cumulative pattern which we have to go about for important chapters, and mole concept is important chapter for every chapter to come ahead. I have repeatedly told you, right? So if anyone has anything to ask me from here, do ask me in the class right now. Yesterday's worksheet, all solved, no doubt. That's such a great thing. I'm really happy if all solved and no doubt. So see, I do encourage you all when you are solving a worksheet, you try to solve on your own, and if your friend is unable to solve, do help each other. But I don't entertain this during the lecture. So there are separate times given to you, right? One during the lecture you can't do this. There is a worksheet time where yes, I want you all to sit together and solve. That's not a test. That's a worksheet solving time given to you. So if someone is solving and you don't know or you are making a mistake and you do learn very much when you sit together and do it. I do agree. Okay, from your friend you can come to know maybe a much better way of solving it, and all that happens. So worksheet solving, do discuss amongst each other who gets what, all that is good. Okay, together you can build, but see to it that you do something constructively. Worksheet solving, you're not doing masti only. Am I clear? Okay, utilize that time for something positive. So I'm so happy that you did this. I go ahead with then structure of atom. So yesterday, like, I'm almost finished defining you everything regarding energy. I gave you ionization energy, ionization potential, binding energy, made you understood first excitation state, excitation energy, all that is given. Tell me how many problems I did based on this. Couple of problems are done or not done? Only one more we do and I teach you ahead. Just one more problem we are doing and I'll teach you ahead. So are you understanding the meaning of hypothetical species here? So you don't have to assume that it is hydrogen. So what changes, tell me? No, bacha. When we substituted, okay, in the formulas and we simplified, right? I substituted. There were big formulas for radius, energy, velocity. We substituted some data. That data was for electron and of hydrogen, right, mainly. So here they say second excitation energy of an hypothetical species, what will change is that constant part will change. You can't assume that constant as minus 13.6 here. Am I clear? And Z also. So yes, because hypothetical species, you don't know atomic number. You can't assume atomic number as 1, 2, 3, 4. We can't assume. So moral of the story is, see, I'll try to give you hint. And all this is what IIT asks, not state substitution in the formulas. And this is what you have to eventually learn by practicing. So what was our formula? Tell me, what was your formula to calculate energy? Basic formula of two levels, En2 minus En1 will be equals to, what is the formula? This is hc by lambda. So nothing, no doubt in this. But when we individually calculate energy, what was the formula for energy of nth orbit? Yes. So my whole point to you is minus 13.6 and a z square comes and a n square comes. Now here second excitational energy means it is going from 1 to 3. So that 1 to 3 is correct. That is, you have an idea about M. But hypothetical species, all this cannot be assumed. We were assuming Z as 1 for hydrogen, everybody agrees. For helium 2. Now, do I have a name of what that element is? No. So, can I assume something as Z here? No. Getting it? Can I assume that 13.6 there? No. So, for these two things, I am helping you to solve. For these two things, you have to assume a constant. So, everybody agree that we can't solve by writing 13.6 and z square. We don't know about it in this hypothetical species. So, I'll just say take this as some k. Negative? Okay, that negative part is some issue in your calculation. The answer comes 98 by 8 but not with a negative part. Did you understood this part what I am talking? Now see, finally I have to find ionization energy. Minus is there. I will put when I will substitute. I'm not, so I'll write minus k, right? Or you want me to assume with minus, and what we assume accordingly we have to act ahead. It is in our hand. So if I say, okay, assume minus 13.6 z square equals to k, then I won't be putting minus. And if I am assuming this way, then I will be putting minus, and I have to do the way I assume. Okay, so if you find it discomfortable, I will do this way, put minus here, and that is k. Then see what happens. So what I am calculating now, energy gap between E3 minus E1, this is what I want to move ahead, everybody agrees? So what it will be, E3 minus E1 will be, K will come, and K into, what is the variable? For all this, so I write k here, okay. Now only 1 upon n square will come. K is something, some constant, I don't know. And some variable will come. What will be that variable? That variable will be the 1 minus 3, the difference, right? So it will be 1 upon 1 square minus 1 upon 3 square. I took care of the negative part. So it works this way better. It works this way better. I took care of the negative part. Are you getting it? So putting minus here, I put minus here, then it becomes even. Getting it? I took care of the negative part. So what will be the answer here? So here, whatever is this energy, let me assume, I'll make it simple. Let me assume this energy, I have to do it in terms of, say whatever is the answer, if that is x. See, I want to get a value of k, I can't solve till I get a value of k constant. Are you getting it? The minute I get a value of k, then only I can go ahead, as I can't assume this. So I'm trying to get a value of k in terms of energy. So when I solve this, what is the value of k I get? My k here will be 9x by 8. Everybody agrees this calculation that I have done. Why I want k? Because otherwise I cannot move ahead. So I got something for k. I cannot assume 13.6 here and z square here. So I got something for k. Now what is the first thing asked? Ionization energy. What is the definition of ionization energy? Tell me. Energy required to remove electron. What it will be? Ground state to infinity. So what it will be? Tell me now in this case. It will be this only, right? What was it for hydrogen? Same. Are you getting it? What I assumed as K. So your ionization energy, and all those who have doubt, I am explaining, see on the board. Go back to your ionization energy definition. Just go back. Check. See, you have to revise and come. You haven't revised, I am making you revise in the class. What is the definition of ionization energy? It is the energy required to remove electron from ground state to infinity. So it is infinity minus E1. And what answer comes for hydrogen? Plus 13.6 for hydrogen. So the answer is coming plus 13.6 into z square. Yes or no? This is the answer coming. Everybody agrees now? So this, what I wrote as K, is actually ionization energy for any hypothetical species. Yes or no? For this species, E infinity minus E1 is going to be this only. So ionization energy in this case, please revise the last lectures and come. If I take a little difficult problem, you won't understand. Is same as K. Is this part clear to you? And we have already known what is K. So what will be the answer? We take the first answer, 9x by 8. And understand, all those who give me negative answer, your ionization energy cannot be negative. Fundamentally not possible. Okay, why? Because I told you, when energy is negative, when given out. When energy is positive, when taken in. So ionization energy is, we have to supply, we have to give to an electron. So electron absorbs that, takes in that. So it has to come with a positive value. If you're getting it with a negative value, you have made an error. There and there you have to understand, I made a mistake. So ionization energy has to come plus. Clear? Any doubt anyone has? Do sit at home with all this. Now how do you define binding energy? Go check yesterday's lecture. You haven't revised. Turn the page, see the definition of binding energy. And it specifically says binding energy but of second orbit. So what was the definition of binding energy? Don't raise the hand to give the answer. Are you giving the answer or asking doubt? So don't raise the hand to give the answer. If you have a doubt, then only raise the hand. Okay. So keep it with you, check it. Any doubt after that, talk to me. So what is the definition of binding energy? Tell me, what is binding energy? So it is not from ground state, right? So if it is from ground state to infinity, ionization. From a given state to infinity is binding. Is the difference clear? Is the difference clear? So here they say from second orbit. So what will be the formula here? Which difference I have to calculate? Infinity and E2 difference. Are you getting it? Infinity and E1 difference is ionization. And infinity and any given orbit difference is binding. Am I clear? Can you try? So we defined, we know what it is. So the second part is trying binding energy. Please try. So your binding energy calculation clearly is E infinity minus E2, and ionization energy by definition is E infinity minus E1. Clear? And what will be E infinity always? 0. Right? So it will be 0 and it will be minus k upon n square formula. Yes or no? So what is the formula to calculate? It will be minus k upon the square, but then this minus and minus k upon, now 2 square will come in my case, right? So this minus of minus will become plus. So this will be 0 plus k by 4. And then substitute for k. What is k? Your k is your k here is 9x. Yeah, he's sleeping right from the beginning. Yeah, yeah, yeah. So this is 9x upon what comes now? Tell me. It was 8, right? And into 4. So what will be the answer? 9x upon 32. And what will be the answer? Not enough. Okay. I made an error in both the answers. Who will tell me what is my error in both the answers? Answer 1 and answer 2 has an error. Who will correct me? No, the sign is positive. Array, I have to write the units. Yes, because they will trick you with the units down. So just getting a number has no meaning. We need a unit. So all this working is in which unit? Electron volt. If our answer given down is in some another unit, we need to work further. Am I clear? So see, all the difficult problem like this, you have to sit with it at home again and again. You try till you understand it. It won't be just putting the numbers in the formula. Understand this. When the exam level is like IIT, board I understand, 11th standard I understand. Some questions in the mains I understand, not all questions in the mains. So you do get some questions in the mains where you directly easy substitute. Some things that I gave you yesterday in the worksheet, some can be that way. Not all can be that way. Are you getting it? Some will be just theory, some will be simple, but some will be difficult. Everybody in the class agrees. Do you know how many people sit for the JEE mains kind of an exam number? Yeah, 15 to 18 lakhs is the number nowadays that people are sitting. And believe me, the theory questions that we just read and take, Rutherford model and all that I gave you, theory, everybody takes. Everybody takes. Okay, then straight substitution in the formula. Okay, maybe 80% can do. Because, I mean, everybody is giving board, everybody in science is 75% plus in the board. Everybody understand how to substitute what is given and how to substitute and get. So 80%, okay, are at the same level. Then, how that least actually comes? Only by those problems which are not comfortable to 80%. Are you getting it? So that up and down that happens. Okay, only when somebody is able to solve a little difficult problem, one difficult problem, you go 1,000 and 1,000 number up by somebody who cannot solve. So you get one difficult problem, your rank is 2-3 lakhs up, and another difficult problem, another 2-3 lakhs up, and this way the grading comes. Believe me, it is this competition. So if you are somebody, ignore difficult, no, then your rank will be below average, because easy everybody is ticking only. So ability to develop to solve a difficult problem will put you few lakh up, and more ability, then the admission will happen. So the whole thing is, you will see, I am pushing difficult problems with you. Whether you understand, don't understand, I am pushing with you. This is the reason. See, I can make you feel very good in the class. Very good by taking very simple goody problems. Yeah, there are goody problems, I know what they are. But then, that is not going to take you anywhere as far as exam IIT is concerned. The minute 6 months down the line, you will start solving PYQ, you will realize that you are unable to solve a single question. So all that goody feeling that you get in the lecture has no meaning. I want to disturb you, I want to tell you that this is the benchmark and you are here, push up. Then only. You have to get up, go up, because the mark is up and you are down. Am I clear? Right? So we will be doing. So this week's exam won't be goody. I have given you 2 papers goody. Now third won't be that good. I'm telling you in advance. First 2 papers were easy. Third paper, chemistry, won't be good. Matlab not that comfortable. It's not difficult. Still, I will mark it as simple to moderate for JEE mains. And I gave first 2 too simple. Now my third exam is simple to moderate. I'm not giving you difficult at all. Not giving you moderate also. All questions moderate, no. Simple to moderate. Is that clear? So start preparing from today, everybody. Okay, little difficult, little. We have to, right? Then only we can solve a difficult one, and when we solve a difficult one, then only our admission will happen. Understand this. Is that clear? Chalo. Now let me go ahead. I'm teaching you something ahead now, new. So we understood Bohr's model. I'm in Bohr's model. Now we can understand something called as spectrum of hydrogen atom on the basis of Bohr's model. Okay, now what is this all about? So I have to ultimately teach you next topic as emission spectrum of hydrogen atom. But I know you are just not aware of meaning of spectrum, what is spectrum. So first in general I will teach you about a spectrum. We will understand types of spectra, and then eventually I'll show you a spectrum of hydrogen atom, and which we can understand. I will explain you some formulas also on the basis of Bohr's model. Okay, so all that is ahead, and again this next part also is an important part. Lot of questions. Bohr model total with spectrum is very, very important as we go ahead. So what is a spectrum? Anybody in the class who knows what is a spectrum? What is a spectrum? Roughly, tell me. There are students here coming from foundation courses, so they must know what is a spectrum. 7th, 8th, 9th, 10th foundation, spectrum, tell me, physics, they teach you in physics. Band of 7 colors. He says, so rainbow, can I say spectrum? Is rainbow a spectrum? No. So what is a spectrum? Don't know. So you can use in your own language. You can have some language, right? We will try to gauge. So what is a spectrum? Nobody is able to put an idea. I'll make you write definition, understanding, take it down. I'll explain you on the board as well. Give the heading spectrum. When a light from a source is passed through a prism, when a light from a source is passed through a prism, light of different wavelengths, when a light from a source is passed through a prism, light of different wavelength get deviated through different angles, get deviated through different angles. This is called dispersion. Different angles, this is called dispersion. Dispersion of light, so at least you understand, right? Something little bit in school. This is called dispersion. Now right ahead. That is not spectrum. Spectrum is something else. Now see, full stop. This is called dispersion. This wavelength composition of dispersed light, this wavelength composition of dispersed light can be viewed by eye. EYE can be viewed by eye when received on a photographic plate. Can be viewed by eye when received on a photographic plate. This is called spectrum. So what you see on a photographic plate. So in simple words, this is called spectrum, right? I'll tell you in simple words what. So it's a photograph of dispersed light, in simple words. And rainbow happens in such a way that we can see it, okay, and that's the photograph of dispersed light that we see in the sky. Okay, so what I told you till now, I need a light and a prism. So this is my prism and I need a source of light. Which light I am using? White light. So everybody understand white light when I say I am using, it is a combination of wavelengths of various lights, right? So the light is entering in a prism and then dotted line is very difficult with this stylus. I am explaining, bacha, wait. I haven't finished explaining. So you understand that there is a change in angle happening now. The angle of incident I am showing you with a dotted line, and this is what is your diffraction. And through the prism, now what comes out? So I am trying to show all 7. This is what comes out from the light, right? Lights of different wavelength, diffracted, coming out from light. This angle is theta. And what is this theta called as? Angle of deviation through which your light is diffracted. Tell me what is on top, which light is on top, which light is down. Yes, on top will be red and here will be violet. So till here you know from school. Bus one step ahead now. What I said, when this is viewed, so I place a photographic plate here. Now this is a photographic plate. And it will take an impression of this. So see, always not possible to see something like a rainbow. Your angle and distance matters. So if all the time you want to view how the light is getting dispersed, you can get the impression on photographic plate, and those impressions are called as spectrums. Is that clear? However it will look, whatever we see on this plate, black color film. So today we click it with a mobile, but previously there used to be manual cameras where a negative complete roll was put. You might have seen old, must be there, film. So that is a photographic film. And on that, when these light will pass, some impression will come. Right? Kind of negative of a photographic film. Negative of a photograph. And that is called as spectrum. But it won't be of any person, it will be of the light here. Diffracted light, patterns of diffracted light. And that will be called as spectrum. So I ultimately have to teach you a particular spectrum under Bohr's model. But I can't start teaching you that directly because you don't have much idea about spectrum. So I'm doing some basic in general. So everybody understood what I'm talking about? Now see, there are 2 types of spectrum. Okay, we classify spectrum under two categories: emission spectrum and absorption spectrum. Emission spectrum and absorption spectrum. That is spectrum there. And this emission spectrum is further divided into two categories: line spectrum and band spectrum. Emission and absorption. Or let me take it as continuous and discontinuous here. So all this I am explaining you one by one. This is the further discussion. So I have to make you understand what is emission, and in that what is continuous, what is discontinuous, what is line, and what is band spectrum. So clear till this? Can we start understanding the first type of spectrum? After this, give the heading emission spectrum. We will start here. So what is the emission spectrum? Simply, there is a source and light is emitted from that source. So that emitted light, if we make it pass through prism, get diffracted and get a picture, that is what is emission spectrum. So a spectrum of emitted light after diffraction, how it looks on a photographic plate, that is a emission spectrum. So give the heading emission spectrum. When a light emitted by a source is dispersed when light emitted by a source is dispersed and received on, when light emitted by a source is dispersed and received on photographic plate the formed wavelength pattern is called emission spectrum. The formed wavelength pattern is called emission spectrum. Formed wavelength pattern is called emission spectrum. Is that clear? Now see, I am explaining you continuous spectrum. And this complete example that I gave you, the rainbow story, is a continuous spectrum. Meaning, a sunlight or a light coming from a tube or a bulb. Given out, right? That light is given out, emitted light. If I pass it through a prism and I get a spectrum, how do this spectrum looks like if this is a photographic plate? Okay. So I should not draw these lines, and I want you to recollect how a rainbow looks. So in rainbow, it is this. But do you see a band or a line in between? No. Okay, when a violet and a indigo and a blue, all that is there, they are almost merged into each other. Okay, there is no gap. There is red and there is a sky and there is next color. Is that the way we get? Or they are all are merged together, so merged that we find them one. Right? It's not that there is a red color, then a band of sky, and there is orange color, and then again some sky can be visible. Do we see this way? No. We see them continuous, and that is what is the continuous spectrum. Rainbow is the example. Okay, so continuous spectrums won't have gaps in between. And this continuous spectrum, I'll teach you ahead, they will precisely look like a barcode. We all have seen barcodes. Okay, so how a barcode looks, some lines and a gap, some lines and a gap. That is what is a discontinuous spectrum. And the way rainbow looks is a continuous spectrum. Did you understood what is a continuous spectrum? So this whole diagram, this whole thing is continuous spectrum. This is the example. So I'll make you write, in emission, you give number 1 to this, give the heading. I'll make you write. Under emission spectrum, we are understanding first one, continuous spectrum. When white light get up. When white light, example can be sunlight or a light from a tube light, bulb, is dispersed through a prism and received on a dark background, and are received on a dark background, into bracket write photographic plate. The entire photographic plate where dispersed light falls the entire photographic plate where dispersed light falls becomes bright. Consisting of 7 colors. Into bracket write Vibgyor. 7 colors into bracket write Vibgyor. The intensity of various colors continuously changes. The intensity of these various colors continuously changes. And there is no boundary. And there is no boundary and there is no sharp boundary, use the word sharp, and there is no sharp boundary between these colors. There is no sharp boundary between these colors. In fact, colors appeared to be merging with. In fact, colors appeared to be merging with. Next color. Such a spectrum of white light contains all wavelength such a spectrum of white light contains all wavelength in a certain wavelength range. All wavelength in a certain wavelength range. What is that range? Tell me. 4000 angstrom to 7500 angstrom, right? So what will be the wavelength range that we talk here about? 4000 to 7500 angstrom. Change the unit, accordingly the numbers to be adjusted. So everybody understood what is continuous spectrum? Now little bit more, as I wrote here about angle of deviation. Can you connect this angle of deviation with a frequency and wavelength? Can you connect this angle of deviation with a frequency and wavelength? You can. It was taught to you because you told me red up and violet down. So you know, but then you don't know as well. Bolo, bolo. Very good. So most deviated is violet means what? Which frequency, which wavelength? What is the connection I have between lambda and frequency? So this lambda, where shall I write? I am writing it here. So this lambda is, sorry, not lambda, theta is directly proportional to frequency. And when I write frequency, also understand this means energy of radiation. And with the wavelength, it will be always inversely proportional, as frequency and wavelength are inversely proportional, meaning where the angle is more, wavelength will be less, and where the angle is less, wavelength will be more. All these kind of questions you should be able to solve. Clear this is? This is school only, but little bit connection ahead. Now frequency to be connected to energy. So what is a high energy visible light, tell me? Which has low wavelength and high frequency. Getting it? Is that clear? So where angle of deviation is low, where angle of deviation is low, tell me, answer me. Red. So where the angle of deviation is low, frequency will be low, energy will be low, but wavelength will be high. So red will be in which range? Last, the 7500 wavelength. Yes. And this has more angle of deviation, so more frequency, more energy, and the wavelength will be less. Is that clear? I've given you electromagnetic spectrum. Open up your CBSE. I want you to do one exercise and everybody will go home and do. Open up your CBSE textbooks. They will be writing numbers against those rays. So do write those numbers. Do write frequency and wavelength looking in the CBSE textbooks in your book. Am I clear? So you have to understand which wavelength, which starts, or which frequency, which radiation starts and ends. Everybody understood the exercise? Copy the numbers for electromagnetic spectrum of frequency given, wavelength given from NCERT textbooks in our books. Is that clear? So you keep looking at that. You will understand what ranges, what comes. Shall I go ahead? Any doubt here? Red has low frequency. Yes. Yes. Because frequency and wavelength is inversely proportional always. Yes or no? So what I finished teaching you is continuous spectrum. Give number 2, discontinuous spectrum. And in discontinuous spectrum, so there are two types of discontinuous spectrum, right? Line and band. So in discontinuous spectrum, give number 1, line spectrum. So now I am explaining you a discontinuous spectrum. So what will be discontinuous spectrum? Now on a photographic plate there will be gaps like a barcode. So there is a bright light and a photographic plate visible, dark in color, and a light and a dark in color, and a light and a dark in color, this way. So discontinuous means this. Is that point clear? And in that I am doing a line spectrum. And actually in a Bohr model, what I have to teach you belongs to this category. So what is our syllabus is this category, a hydrogen atom spectrum, which is a emission spectrum, which is a discontinuous spectrum, and which is a line spectrum. So see, I am explaining you this whole. Now see what happens. I told you in a Bohr's model, see on the board, if I am having a hydrogen atom, there is a nucleus and there is one electron which is here. in the first orbit. This is the case, and this is the case. Understand, when I say hydrogen is in a ground state. And obviously this is n equals to 1. Is everybody making sense to you, everything that I have written on the board? Now see what happens when either I heat this sample or this is exposed to light. The electron gains energy, yes or no? And now I have shown you energy calculations also, but everybody sure, now after this, it will not be in the ground state, it will go somewhere in the excited state. So the electron has jumped from a ground state to excited state. It was originally here, now it has gone up. Is this clear to everybody? Yes. And this energy we are calculating this only till now. Okay. Now after this, what will happen? The excited state electron, because it is at a high energy level, not stable. It is not stable. What all electrons who go at an excited state that they do? They jump down. So it goes to excited state, it is not stable, it will jump down. So I write here, electron jumps down. And down means ultimately to ground state. So the electron was originally here, now it has come down. This is jumping down. Is everybody gets the clarity what I am talking? Now what is emission? It comes here. When the electron is jumping down, okay, along with this jump, it won't happen just like that. What the electron will do? It will give out a photon. Means it will give out light. And this is what is emitted light. Did you understood? Getting it? So this is what is emitted photon, emitted light. And if we catch this on a photographic plate, that is what is your emission spectrum. Okay, but before catching, I have to get it diffracted. So I'll pass this through a prism, this emitted light, and then take it on a photographic plate. And then what I get is one emission spectrum. In case of atomic hydrogen, it is discontinuous and it is line. So discontinuous and line I will explain. But did you got a clarity what is emission spectrum? The emitted radiations, make it pass through prism and take a pic of it. So if you're finished drawing this diagram, give the heading line spectrum. I'll make you write couple of things. When atoms of an element are heated, when atoms of an element are heated or irradiated by light, atoms get excited, an electron jumps. Atoms get excited, an electron jumps. To higher energy level. Electron jumps to higher energy level and become unstable. Electron jumps to higher energy level and become unstable. To gain stability, it jumps down. And emit light. To gain stability, it jumps down and emit light. This emitted light is dispersed. This emitted light is dispersed and the pattern of dispersed light and the pattern of this dispersed light is called line spectrum, and the pattern of this dispersed light is called a line spectrum. So I am drawing it for you. So if this is my photographic plate, how does a line spectrum looks like? So your photographic plate is dark, and when these photons are given out, it will appear as a bright and very small line. And then this part will be dark, photographic plate darkness. And then there will be a gap and another line appears. Are these lines of equal width? Answer is no. They are like your barcodes where you see some big lines, some small lines. Right? So there can be gaps also and a line will appear. And this way. So this is what is a line spectrum. Thin lines. But in that thin lines, the thickness is not same. So this is what is line spectrum. So a line spectrum has thin lines on dark background. And this is not continuous. After a line, you will see a photographic plate, that is what is the dark part. And then again a line and again a photographic plate. That is what is the whole meaning of discontinuous. Line because the light will appear as a line, thin lines. And you get a line spectrum when you have a sample of atoms, atomic species. So hydrogen atom sample or similar atoms are there, then we get a line spectrum. So if this A part is over, then we will do the B part, band spectrum. Have you finished with A part? So what will be band spectrum? When we get band spectrum? When your sample is some complex molecules, not atomic species, complex compounds. And when we make them undergo a similar process, what they give us is a band spectrum. What is the only difference? The lines that you see are broad, or the lines are so close that they appear to be a band. So a band spectrum, if I have to draw, it is, I can say this way, a closely placed lines which are appearing like a band. So this is a band, but in that many lines are very closely placed. And then there will be another band and so on. There can be big gap, small gap, band size varies, all this thing will happen. So band spectrum, the lighter part is little thicker than line spectrum. So kind of a barcode only that you see, but it is a reverse of barcode. You'll agree? This is reverse of barcode. Barcode, the background is light and the lines are dark. So I say reverse of barcode. Here the background is dark and the line is white. Reverse. Thin lines on dark background. How is your barcode? It is white, right? And on that black lines. So barcode is bright background and dark lines. This is bright lines on dark background. Did you understand this? This is reverse. Appearance is like barcode, but it is reverse. Both of them are that way only. So these are, so this is basically a band spectrum. So bands means there are many lines merged to give us a bands. So bands on is this clear till here? Any doubt anyone has? So what remains is another kind of spectrum called absorption. I'll do next lecture when we are fresh as something to be understood there. But is emission spectrum clear? And then tomorrow I'll be starting with this hydrogen spectrum. So you can revise, and I've given you one homework today, specific homework. What is that homework? Harsha, tell me, what is tomorrow's homework? No. Specific homework. Revise is a everyday story. So Indira knows. Do you know what is tomorrow's homework? Mohit, what is tomorrow's homework? Yes, spectrum what? What in spectrum I told you to do? Adesh, what is tomorrow's homework? Clueless. Alok, what is tomorrow's homework? No. Something else was told to you. What in NCERT? Wavelength of what? Electromagnetic spectrum from NCERT. Copy the frequency wavelength numbers in our book. I gave you without numbers because first I wanted to understand sequence for you. Now I want you to understand with the numbers. So do that needful. Okay? That's it for today. See you tomorrow.